Hello, welcome to my channel. We will be doing question number 4 and onward. Uh, let's start this question 4a. It is interesting. So what we will do, you see, this is a smaller number and this is a bigger number. So I will assume that this x power 1 by 6 is equal to some y. So if I make square on both sides, so x power 1 by 6 square will be x power 1 by 3, and that would be y square. So now substitute these values in this equation. So it will become y square minus y equals 2 or minus 2 equals 0. So this can be factorized as y uh, plus 1 and y minus 2. Am I right? Because when you multiply it becomes minus 2 and y and 2 minus y. Yes. Okay, so from here we get the solution that y is equal to minus 1 or 2, right? It means this x power 1 by 6, which is equal to y, this is equal to minus 1, or x power 1 by 6 equals 2. So this is the case if I raise both sides by power 6. So x is equal to minus 1 power 6, and that is going to be 1. And similarly, x here is going to be 2 power 6, and that is 64. Okay, so now we have two solutions. One is x equal to 1 and one x equal to 64. Okay, let's confirm these answers. Okay, if I put x equal to 1 in this original equation, so x power 1, sorry, 1 power 1 by 3 minus 1 power 1 by 6 should equal to 2, but 1 power 1/3 is 1, 1 power 1/6 is also 1, so this is 2, it is 0 equal to 2, so this is not correct. It means this solution is not valid, it's not correct. Okay, now let's check the other solution. 6x equals 64, so 64 power 1/3 minus 64 power 1/6 is equal to 2. Is it correct or no? So 64 power 1/3 is going to be 4. 4 power 3, 4 times 4 is 16, 16 times 4 is 64. So 4 power is the cubic root of 64 is 4 minus, and the sixth root of 64 is 2, right? 2 to the power 6 is 64. Okay, so this is equal to 2. Yes, this 2 is equal to 2. So this is correct. So this solution is good and this is not good. So my solution is x equal to 64 only. Okay, this is the solution of this equation. Okay, now let's do question B. Um, Here, this first part is just they're trying to confuse you. Okay, remember, whenever log of something is 0 for whatever base, right? Okay, let's put base 10 for convenience. Right, so if log of something is 0, it means that 10 power 0 is equal to that thing, and 10 power 0 is equal to 1. So this thing is equal to 1. So instead of writing this equation this way, I will simply say x plus 2y is equal to 1. So these are the two equations. One is this and one is this. Okay, so from this first equation, you can see that x is equal to 1 minus 2y. So I will substitute this value in the second equation. Second equation is x squared plus 4xy plus y equals 1. So x squared means, let me do it over here, 1 minus 2y squared plus 4 times x is 1 minus 2y into y plus y, and let's say minus 1 equals 0. So when I open this square, it is 1, and minus 2 times 2 is 4y, and plus 4y square, and this is going to be plus 4y and minus 8y square plus y minus 1 equals 0. Okay, so this 4y squared and minus 8y squared. This is minus 4y squared. And then we have minus 4y cancelled with 4y, and I have y only. And then constant term 1 minus 1, this also is cancelled with each other. So I have everything, this is equal to 0. Okay, so if I take y common, it's going to be 1 minus 4y equals 0. So from here we get the solution that y is equal to 0 or y equals 1 by 4. Am I right? Okay, so with this I can substitute it in here. So if y is equal to 0, then x is equal to 1. And if y is equal to 1 by 4, then x is equal to 1 minus 2 times 1 by 4. So 2 times 1 by 4 is 1 by 2. 1 minus 1 by 2 is 1 by 2. So our solution is x is 1 and y is 0. This is 1. And the second one is x is 1 by 2 and y is 1 by 4. So this is our solution. Okay. I hope it's clear. No confusion, no nothing to ask. Okay. Solve this thing. Okay. It's very obvious that 5 times 2x minus 1 absolute value is going to be 23 minus 8, which is going to be 15. And if I divide by 5, so 2x minus 1 absolute value is going to be 15 divided by 5 is 3. So since absolute value, this expression is equal to 3, we can say that 2x minus 1 is equal to 3, and 2x minus 1, its negative value is also equal to 3. Because if it's negative, then absolute value is going to be positive. So from here, you can see 2x is equal to 3 plus 1, 4, and x is equal to 2. And from here, 2x is equal to minus 3 and minus 1, so it is minus 4. So x is equal to minus 4 over 2 is minus 2. Sorry, I think I made a mistake here. Yeah, this is minus 3, and it will be plus 1, so it's minus 2, sorry, yes. So minus 2 divided by this is going to be minus 1. So my two solutions are minus 1 and 2, right? So these are my two solutions. Okay, now this question, okay, this is easy. Yeah, I can't say this difficult. Remember, I need some space to do this one. If I have y equals sine x, if I'm to plot it from 0 to 360 degree, you know, it is this shape. It goes from 0 and again 0, and this is where. Okay, so this is 360. At 180, we have 0 again, and it goes from plus 1 to minus 1, and this point is at 90 degree where it is maximum, and this is 270 degree where it is negative 1. Okay, so if I have y equals 5 times sine x, I just need to stretch this graph in the vertical direction by 5 times. So it has the same shape exactly. Just this point is going to be 5, and this is going to be minus 5. And it is 360 as before, and 180 and 90 and 270. Okay, and if I have y equals 5 sine x minus 2, it means I just need to pull this graph down by 2. So instead of this 5, it will become 3. So 1, 2, 3. And minus 5 is going down by minus 7. So 1, 2, 3, 4, 5, 6, 7. Here it comes over here. Okay. And the middle of these two is minus 2. Okay. Here, so minus 2. So graph will start from minus 2. It goes to plus 3. Go back to minus 7. And comes back to minus 2 again. So this is minus 7, and when it reach here, this point is going to be 360 degree. Okay, so let's try to make a sketch over here. So start from minus 2, and at 90, this is 90, it is going to be 3. So 1, 2, 3, it will be over here. And at 180, it is going to be minus 2 again. And then 270 is going to be minus 7. And back to 360, but minus 2. Okay, so you can imagine it's going to be something like this. And here, 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 and here. It touches minus 7. Okay, so something like this. I hope it's clear. Let's move on to the next question. Yes. Okay, this is a bit challenging, a little bit challenging. Okay, so what do we have to do? We have to find the derivative of this thing. Okay, so y equals x square minus 1 over x square plus 1 and its power 4. So dy by dx is going to be 4 times x square minus 1 over x square plus 1 power 3, and the derivative of this thing. Okay, for this we need to use the quotient rule. So square of the lower function x square plus 1 and its square. Now lower function, so x square plus 1 into derivative of the upper function, that is 2x. Okay, 2x minus upper function, that is x square minus 1 into derivative of the lower function, which is again 2x, and divided by the square of the lower function. Okay, so let's try to simplify it a little bit. It is going to be 4 and x square minus 1 power 3, and denominator is going to be x square plus 1 and power 3 plus 2, 5. And here, how can I say, okay, if I multiply this, open this bracket, this is going to be 2x cube, okay, plus 2x, and this is minus 2x cube, and minus 1 is plus 2x. So 2x cube cancels with minus 2x cube, and 2x into 2x is going to be 4x. So my final answer is going to be 16 and x square minus 1 power 3 over x square plus 1 power 5. And sorry, this is 4x, so this is 16x here. Yes. Okay, so this is my final answer. Now, if you compare this expression with this one, okay, you can see that A is 16. Okay, we have everything there. X is there, x square minus 1 power 3 is there, x square plus 1 power 5 is there. So A is 16. Okay, so this is the end of this problem. Now, next problem, part B1, show that the curve has stationary points where x is this. Okay, remember we found that dy by dx was 16x into x square minus 1 power 3 and x square plus 1 power 5. Right? Okay, in order to find the stationary point, I need to put this thing equal to 0. I have to equate it to 0. Now you can see that when I make it equal to 0, this denominator has no impact. The denominator will not make it 0. So this is 0 only when x is 0 or x square minus 1 is 0. Okay, is it clear or no? Because you can see that, okay, if I try to solve this equation, this thing, when it comes onto the right side, it multiplies with 0, becomes 0. So I have 16x into x square minus 1 power 3 is 0. Again, I bring 16 on the other side, it will become 0. 0 divided by 16 will become 0. So I can cancel this thing as well. Okay, from here you can see that x has to be 0 or this part, right? In fact, x square minus 1 has to be 0 because when this is 0, its power 3 is also 0. So we have only these two possibilities. And from here, you can see that x square minus 1 is x plus 1 and x minus 1. If this is 0, it means x is equal to negative 1 or plus 1. And the third solution was x equal to 0. So only these are the possibilities, or these are the stationary points of our curve. Okay, so we did this problem. Now this part, last part, this is a bit tricky. Use the first derivative test to determine. Okay, so you can see that on our x-axis, the stationary point is at 0, at plus 1 and minus 1, right? So the graph is either have maximum and then minimum at 0 and then maximum again over here, or minimum at minus 1 and then maximum at 0 and then minimum again at minus 1 plus 1. Okay, how can we decide this thing? Either we need to find the second derivative or we can do the following. You see, I will make a table like this. Okay, so when value of x is less than minus 1, when x is less than minus 1, or when x is between minus 1 and 0, and when x is between 0 and plus 1, and when x is more than plus 1. Okay, so these are the things which I want to evaluate, and I need to find the derivative dy by dx in this range. And actually, I don't need the derivative, I just need to know the sign of the derivative. Okay, remember derivative we found as 16x into x square minus 1 power 3 and x square plus 1 power 5. Okay, so let's see. Let's take when x is equal to minus 2. I just took one number at random in this interval when x is less than minus 1. So I just took this number. Okay, so at this number, what is the derivative? Okay, I don't need to evaluate the complete derivative. I just need to know the sign of it. Is it positive or negative? You see, when x is negative 2, this is going to be negative 2. And then negative 2 square is 4. 4 minus 1 is 3. 3 cube is some number, but it's going to be positive. Okay, so positive times negative is negative, divided by, again, x is minus 2 square is plus 1. So this will be positive. So this whole thing is negative. So in this interval, my derivative is negative. Okay, now what about between 0 and minus 1? So let me choose a number between 0 and minus 1. So that is x equal to minus half. Okay, so when x is minus half, you can see that derivative is going to be x is minus half, so it is minus 0.5. Okay, when x is minus half, its square is going to be 0.25, right? And it's positive. So 0.25 minus 1 is going to be minus 0.75, and when I raise it to power 3, it's going to be a negative number again, right? Okay, and divided by, again, when it is 0.5, negative square is positive, add 1 is positive, raised to the power 5, it's going to be some positive number. Okay, so this negative time negative is going to be some positive number, right? So in this interval, my derivative is positive. Okay, in the same way, if I try to evaluate the derivative in this range, 0 and plus 1, so let me say x is equal to 0.5. Okay, so in this range, what happens when x is 0.5? This is a positive number, and 0.5 square is 0.25 minus 1 is minus 0.75, and it's called cube is negative. So I have a negative number here, and the denominator is going to be positive again. So overall, it's going to be a negative. So in this interval, we have a negative number. negatives. Okay. And in the same way, you can check that when x is more than positive 1, let's say plus 2. So if x is 2, the derivative is going to be 2, and 2 square is 4, 4 minus 1 is 3, 3 cube is again positive number. Okay. And divided by this is going to be positive again. So this is a positive. Okay. So, what does it mean? You see, when x is less than minus 1, the slope was negative. So, it means the function was decreasing. Okay. And between minus 1 and 0, the slope is positive, so the function was increasing. Okay. And between 0 and plus 1, again, the derivative was negative, so the slope is negative. Okay, and again from plus 1 onward it is positive. So these minus 1 and plus 1, they are the minimum points. Okay, use the first derivative test to determine which two stationary points have the same nature and state whether they are many. Yeah, so minus 1 and plus 1 are minimum points, and 0 is maximum point. Okay, I hope it's clear. I'm not confusing you. This is the end of, yeah, no, then next question. Yeah, we will do it in the next video. I hope this everything is clear. If you have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.